Okay, welcome to the first lesson in Unit 2. We are moving just a little bit from the use of right triangles and studying about right triangles and using SOHCAHTOA to looking at something that works on any triangle, not just a right triangle. So I wanted you to look at this triangle right here that we're given. This is just your basic obtuse triangle. It's called triangle ABC. Notice that the angles are all capital letters, and the sides opposite are the same letter with a small. So there's small a, lowercase b, lowercase c. Okay, so one of the first things that we're going to use is the law of sines. Now the law of sines is going to have sine in it, which kind of makes sense if you think about it. It works on oblique triangles, so they don't have to be a right triangle. In fact, they most of the time will not be. And we talk about here, when do we use the law of sines? Well, there's basically two cases. And this goes back to geometry class when we used postulates and theorems to prove that two triangles would be congruent to each other by using three different pieces of the triangle. There were side, 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 angle, side, angle, angle, side, and hypotenuse leg. And so we would use the law of sines if we had these two configurations. On number one, we have angle, side, which if you'll look down here on the triangle, if I have an angle, and a non-included side, that would be an angle, side. So you'll notice here that I have an angle across from a side, an angle across from a side. The other configuration is angle, side, angle. And I'll show this one on this triangle. I've got an angle, another angle, and the side in between. So angle, side, angle. And one thing you'll notice here on this particular situation is that I can find this third angle because I know that the three angles of a triangle add up to, that's right, 180 degrees. So I can find this. I can always find this third angle. And then that would give me an angle across from a side. All right, so in both of these situations, I would very much be able to use the law of sines. The second option, number two, we will talk about tomorrow because it is not a congruence postulate. It's side, side, angle, and you can see what that spells backwards. It's not a congruence postulate. It actually results in three different cases. And so we call this the ambiguous case. And we'll talk more about that one tomorrow. All the ones today, you'll be able to solve one triangle, and that will be all. Okay, this is the law of sines. And once again, you can see the triangle, that ABC triangle. It doesn't have to be ABC. It just happens to be on here. You could be XYZ, QRS, matters not. But you'll notice that it's the sine of an angle. And then the ratio is the side is above it. The side across from it is above it. Same here, same here. Now, you can see it's written with 3. We don't ever use just 3. We use any 2, generally, to solve. And these are proportions. A ratio equal to a ratio is a proportion. And so we use a method called cross-multiplying, but I'll show you, basically, once you get the hang of it, it's just a calculator problem. Notice that as long as I have all the signs in the numerator and all the sides in the denominator, I can use it, or flipped over. But write these down in your notes, please. Okay, just a reminder about an altitude. The altitude is the height of the triangle. It's also the shortest distance from the vertex to the opposite side. The height of the triangle is what we use to find its area. So in an acute triangle, the altitude, that was lovely. Let me try that again. Oh, I can change colors. That'll be interesting. The altitude would go from the vertex perpendicular to the opposite side. This is the altitude. Oftentimes they call that the height. In a right triangle, the altitude is actually a leg. It could be either or, the other leg. In an obtuse triangle, and this is just barely obtuse, the altitude is outside the triangle. And so it would look like that. But that's also the height of the triangle. Okay, this is our first example. Once again, you see an ABC triangle. And the example one says to find the length of B. Okay, so what we want to do then is set up the law of sines. And I notice here that I have an angle across from a given side. And so I'm going to start with that one. For some of you, this is a review, and you'll want me to get going here on this, but the sine of 108 degrees. Notice I'm in degrees, so your calculator also needs to be in degrees. So the sine of an angle across from a given side is going to be equal to, and what I want to solve for is B. So I'm going to put side B in the denominator, and then I need the angle B. So I'm going to do the sine of angle B, which is 33 degrees. Okay? Now, solving a proportion, what I'm going to do is I'm going to multiply both sides by 24. So I'm going to have the sine of 108 equals 24 times the sine of 33 over B. And then I'm going to multiply both sides by B. So I have the sine of 108 times B, equals 24 times the sine of 33. To solve for B, you would divide. So I wrote this out because I want you to see that there's a pattern here. So if I have 24 sine of 33 over the sine of 108, and that's going to equal 13.74, and I hope somebody has a calculator and they're double checking me on this. But what I wanted to tell you was, if you'll look at this, you would take 24 times the sine of 33 and divide by the sine of 108. And we're going to do that every time. You do not have to write this out all the time, but once again, if you don't understand this problem or you haven't done it before, you will want to write it all the way out. So the length of B is 13.74, not degrees, because we found the length of a side. All right, on this one, we have an angle side configuration. And if you look at this, you can see that we have angle A, we have angle C, and then we have side C, which is over here. You can see angle, side, which is why I have written up here. The other thing that's different about this, instead of finding just one missing piece, we're going to solve the triangle. That means that given 3 pieces, we're going to find the other 3 pieces. And so that's where we want to begin, because we want to write down the 3 pieces we need to find. And I would not skip this step. I would do it every time. So I have a capital A, a capital C. I need to find angle B. That's the first thing. I have side C, and I need to also find side A and side B. Writing it down somewhere on your problem is the added advantage of making sure that you've completed the problem. All right, so far that's what I have. All right, so I'm looking at the given information, and I see that I have an angle C across from a side C, and that's where I'm going to begin. So I'm going to write the sine of 54.6 over 2.68 equals. Now, at this point, since I'm given angle A, I'm going to go ahead and write the sine of 24.3 degrees, and then that would be over angle A. So that's what I'm looking for now, is angle A. All right, so I'm going to multiply 2.68. I'm going to multiply 2.68 times the sine of 24.3, and my calculator needs to be in what mode? Right, that needs to be in degree mode, so make sure, stop the tape, make sure it's in degree mode. You should be following along and doing this on the calculator at the same time so you can practice it. 2.68 times sine of 24.3, and hit enter, and then hit divided by the sine of 54.6, close the parentheses, hit enter, and when you do that, you will get the answer of 1.35. And that's a side, so it's not degrees. Don't put degrees on it. Okay. To find side B, I'm going to start with the same thing, the sine of 54.6 over 2.68. There's no reason to reinvent the wheel. This time I want to solve for side B, so I need angle B. Don't have angle B, but I can get angle B, so maybe we need to start there. I know that the three angles of a triangle add up to 180 degrees. So on my calculator, I'm going to do 180 minus 24.3 minus 54.6, and I'm going to write the angle for angle B, and I got 101.1 degrees. And be sure and put the degrees on there. All right, so because I have that now, I can change this to the sine of 101.1 degrees. And once again, I'm going to multiply 2.68 by the sine of 101.1 degrees and hit enter. And I'm going to divide it by the sine of 54.6 degrees. And when I do that, I should get, if I did it right, 3.226. And so there's your problem. And so we've now got all three pieces, we've solved all three parts, we've shown our work, and so this would be sufficient. Okay, one more example. We have another one. This is triangle DEF. It says find side E to the nearest hundredth. You'll notice up here at the top I have angle, side, angle, because what was given was an angle, another angle, and the side in between. And so we're going to use that then to solve for this side over here, E. Okay, so I have all three angles. That's kind of handy. All right, so I have, I'm going to go ahead and set up the sine of 54 degrees over 7 because they're across from each other. And then I want to solve for E, so I need the sine of angle E, which is 67 degrees, over side E. All right, so once again, I'm going to multiply 7 times the sine of 67, hit enter, and divide by the sine of 54. And if I did it correctly, I should get 7.965. Okay, now that you found E, you can see that it wouldn't be all that difficult to find the remaining side, side D. And we can set up the sine and cosine the same way. So using the law of sines, I would say the given side, sine of 54 over 7, is equal to the sine of angle D, which is 59, over side D. And then we would use the same method. We would say that the sine of 54 times D is equal to 7 times the sine of 59, and D would equal 7 times the sine of 59 over the sine of 54. So D would equal 7.42 with a little bit of rounding. And that makes sense. I mean, if you think about it, look at the triangle. You have three angles that are very similar, not very much difference between the angles, so the sides are all going to be very close to the same. And none of them are going to be like a hypotenuse or anything like that. But the longest will be across from the biggest angle. Okay, on this final one, this is homework. I want you in your composition notebook to draw the triangle, to solve it using the law of sines to find the missing pieces, and have that in your composition notebook ready to be checked the next day. It's not board work, it's actually part of the video here. I want you to try this on your own, and I will have the answers for you in class. See you then.